So we have, again, this is page 153.
Yeah, I was like, this is a 7.
We have y equals the cosine of the sine of x. Okay.
Yeah, I don't think the U thing. I thought that was
You
really
can
easy.
apply u substitution if you want. If you want to, I don't teach it this way, but if you wanted to do the chain rule defined on page 149, they say that dy dx is equal to dy over du times du over dx. So if you were to do f of g prime of x, they're saying that that is equal to f prime of g of x times g prime of x. It's a lot of mathematical words and terminology being used here. But when I teach chain rule, I just say, okay, outside in, and then keep going in, and that works for everything. So you can ignore the u. You can ignore the u.
I just didn't understand what they wanted us to do for 9 and 11. I didn't get it.
Oh, we'll get there. All right, so we'll get there. So let's do 7. So y is equal to cosine of sine of x. Okay. So if we want to find dy dx or y prime. Okay. So dy dx equal to, okay, so yeah, the derivative of cosine in general is negative sine. So we can text on our phones or whatever we're doing on our phones. So we have negative sine of the guts stay at where they are, and then times the derivative of the guts, which is going to be cosine. And then they just wrote it, they left it as in the text, they actually left it just like that. That's fine.
But can you simplify it?
In fact, I'd probably, I would leave it like that, yeah. It wouldn't look any cleaner to put cosine x in front. And this doesn't really simplify it. This is not like negative sine squared of x. So let me distinguish that. It's a good question. We have this. Let me show you something. Hopefully a little glitch here. That's okay. Hopefully. If I had the negative sine of x, say times the negative sine of x, this would be sine, simplified as sine squared of
It's
x.
because sine of x is the x of sine.
Sine of x is the x of sine.
Like, it's sine of sine of x. It's not sine of x.
Yeah, so this here is saying, okay, the opposite
Yes.
of the sine of the sine of x. Yeah, exactly.
I see.
Yeah. So we can't go any further simplifying this here. Okay. Oh, we could look at the one that was the exit ticket. Let's see how far that went. That was from, I think we got that. We left it off here. Yes. Right, this was the exit ticket from yesterday. You guys have to complete this? Yeah? Alright, let's look at this real quick. I want to see what you guys got. Because I think this, if I remember correctly, it's simplified down pretty well. And this guy's done. So this one, edit, page. Oh, what did I do? I didn't copy it. Let's try again. Edit, select all. Edit, copy. No. Here we go. Alright, we'll get there somewhere. Alright. Select all. Can I get up a little bit? Okay, so let's continue. Yeah, this was the exit ticket from yesterday. So let's see how this works out here. I thought it was the exit ticket. But anyway.
We just didn't go over the answer.
Oh, okay, but it was something we did at the very end. Okay, so yeah. So let's see what we got here. So we have y prime is equal to, this guy's, he's pretty much simplified here. We have 2 sine of x over 1 plus cosine of x. So to review this, chain rule, 2 to the front, leave it alone, drop it down, and then the derivative times the derivative of the inside. Okay, so now let's see what this is, times. Now, this here is going to be quotient rule, right? We have the big picture here is quotient. The derivative of the top, the derivative of the top is cosine x. Leave the bottom alone. Minus, leave the top alone, times the derivative of the bottom, which is the negative sine x. Right? I could write 0 plus negative sine x, same thing. All over the bottom squared. Please ask any questions about it. I know quotient rule can be a little nasty. It can be a little complicated.
Wouldn't you have to put the second half of that minus sign in parentheses? Well, I just do that to make sure that I remember.
The second half of the minus
Like
sign?
after the minus sign,
After this minus sign?
you have to distribute that minus sign, right?
Yeah, like if we had like
Okay,
a sum,
I'm just thinking,
yeah.
okay.
If we had a sum, yeah. Yeah, okay, so, no more questions, everyone understands this? Okay, alright. Alright, so let's see how this works out. So it's especially important to know how to see things simplify as much as they can, especially you take an exam and let's say it's multiple choice like the AP Calc exam, part of it is, and the choices aren't looking like what you have because you weren't able to successfully simplify it as much as you could. So let's see how this works out. See if we can go any further. Yes, you may. Alright, so here we go. Okay, if I distribute this cosine of x, ooh, I may have, of course, one of those Pythagorean, no wait, that's not going to be positive sine squared of x. I don't know if this goes any further. So you're looking at it.
Like cosine. Yeah. If you multiply, it would be negative sine squared of x when you multiply.
Did I make a little mistake here? Hold on, derivative of this one minus, little boo-boo, okay. Yeah, okay. Then the root of this bottom, okay. Alright, so I do see you guys the Pythagorean.
I was wondering if we could use those, because I see that sometimes.
Pythagorean identity, you guys remember those? The ones that they expect you to have memorized, like sine squared theta. Okay, let's go sine squared
Cos
theta.
plus is 1.
You guys remember the other two?
We didn't memorize them.
Okay, I hear you.
For once I know something.
What's that?
For once I know something.
What is it?
I know this. What are the other two?
Say it loud and proud.
What are the other two?
The tangent and secant, something like that.
You know the Pythagorean identity? Which can be derived from this guy.
It's the,
I don't memorize it either.
sine squared theta equals cosine squared theta.
Okay.
It's just opposite. And just like, say
Yeah, it's like cosine squared theta, so there's 1 minus cosine
There's
squared
one with
theta.
Well, that's-
tangent and
Yeah,
a
one of the ones that involve a tangent. So here's how you come up with them. So
tangent squared theta equals secant.
So here's a trick here where I don't have to memorize all three. I memorize one and I get the other two without having to memorize all three. What you want to do is, if you divide this whole thing, so this is one of them. In fact, let's do this. It's not really part of this problem, so we'll go with black. And we'll say, okay. So if I divided this whole thing by sine squared of theta, I would have 1 plus, now cosine over sine is, yeah, it's cotangent, so cosine squared theta over sine squared theta, yeah, cotangent squared theta is equal to, again, imagine dividing the whole thing by, in fact, I want to show it. If I divide the whole thing by sine squared theta, right? This is one of them. So let's make it put this is one of them. And the last one, 1 over sine squared theta. Okay? Do we know the reciprocal to, this is the reciprocal of sine squared theta. Yeah, the reciprocal of sine is cosecant. Yeah, so the reciprocal of sine is cosecant. So 1 plus cotangent squared theta is equal to cosecant squared theta. So you don't have to memorize, you memorize this guy and then divide by this guy, the whole equation, and you get the other one. And then if you divide, went back to the original, and divided this guy by cosine squared theta, you would have, tangent squared theta plus cosine squared theta divided by.
Wait, what are you dividing it by?
Now cosine squared theta.
Oh.
Right, let me just go ahead and show it.
Wait, how are the same things different?
What's that?
No, this is a totally
This is
different
a
thing.
totally unrelated thing to the
Yeah.
problem.
It's not totally unrelated to the problem. We're definitely going to probably end up using this for the problem.
I did.
Yeah, but while we're here, let's go over the other two that you're supposed to know. Okay?
You don't have to use that.
Sine squared theta. You didn't have to work out algebraic, it's something else. If I divide the whole thing by cosine squared theta, you would have sine squared theta cosine theta is equal to tangent squared theta plus 1 equals, now 1 over cosine squared theta would be, 1 over cosine squared theta would be secant squared theta, good. Alright, so there's the other two. And I don't know if that was ever pointed out to you. It wasn't when I taught this course, but I wish it was, because then you can come up with the other two naturally. Okay, so let's continue.
It's a tangent. Oh my god.
Alright, so we have this guy's still the same. Okay, so look at this. Nothing really, the way it's, guys, the way it's written right now, I really can't do a whole lot. It's the way it's, the way it's written right now. And there's nothing to really factor out.
Just simplify it.
Right? So let's go ahead and let's simplify it, yeah, because nothing really makes sense right now. So I have cosine of x times 1 plus cosine of x. Let's go ahead and distribute that, because I see, it feels like I see a cosine squared x, maybe plus the sine squared of x. Looks like, yeah, negative, so let's see here. So we would have cosine of x plus cosine squared of x. Now, plus sine squared of x all over 1 plus cosine of x squared. And I'm not gonna expand this guy right now. I really don't see an advantage to it right now. You guys okay?
Sorry. She's
Oh, so we now.
You have this one.
Shoot this down a little bit more. I want to do this. It's kind of small. Let's see. You guys, if I shrink it down a little bit, it'll be okay?
Are you
A
gonna?
little more? Alright.
I mean, this isn't wrong. Like, what we did, it's just not. So you should.
Alright, so if we continue with this, y prime would be equal to 2 times sine of x over 1 plus cosine of x times. Now, cosine squared x plus sine squared x is 1. So we have 1 plus cosine of x over 1 plus cosine of x squared. And now this got really convenient real quick. So I can see that it doesn't matter how I simplify this, whether it be diagonally or directly up and down. that I think would be about as far as we can go here.
Can you do it, if I don't use that, because I didn't use it, and I didn't get that.
Let's see what I'll compare to what you got here. We have 1 plus cosine of x squared. What did you do?
Okay, I did, instead of simplifying that to 1, instead of simplifying cosine squared plus sine squared to 1, I just simplified it, like canceling stuff out.
What did you cancel?
Well, I what is it called? Foiled the bottom.
Oh, okay, you
And then-
expanded this?
Yeah, I expanded it and canceled stuff out.
So,
We got that extra, we got 2 signs.
now remember, now be careful, when you're canceling up and down diagonally, we need to have a product.
Oh, because you can't do that because it's addition.
Yes, be careful here.
Okay,
It's
thank you.
there.
Now I got it. So, instead of that.
Any questions about this? Where it gets maybe fuzzy, you want me to clarify something?
No, we got that one. Yeah, I just had a question. So it would
Okay.
be.
Staggering identities.
Are we doing over the home?
Yep, we're gonna continue homework, yep. So back to the homework. Number 7, now we're on number 9 on the homework. All right, so number 9, it says,
I don't. It doesn't ever ask you to derive it. Like, what is it asking you to do? Like, yeah, I found the derivative just because I was guessing that was just supposed to do, but it doesn't.
number 9 says that an object moves along the x-axis so that its position at any time, where of course t is greater than or equals 0, is given by x of t is equal to s of t. Find the velocity of the object as a function of t. Okay, we have s is equal to the cosine. Can you please sit over here? I'm asking you. Can you please sit over here? After I ask. S is equal to the cosine of I over 2 minus 3t. So an object moves along the x-axis so that its position at any time is given by this. So x of t equals s of t. Okay, find the velocity of the object as a function of t. So we know that the derivative of position is velocity. Position equals velocity. You guys remember the next one? Acceleration. And then jerk. And the next one? Snap. Crackle and pop.
Is that joke or is that serious?
Both. I think it's both. Okay, so if we find, and then lock and drop, I think, is the next one. So anyway, we're not going to go that far, but anyway, so the derivative of this would give you velocity. Okay, so we know that s prime of t, we're going to try s prime or s prime of t, is equal to, okay, so here we go. So the derivative of cosine is, in general, is negative sine, and then leaving this alone, and then times the derivative of the inside, which is just negative 3. All right, we have a constant, which is 0, and derivative of negative 15 is negative 3. So this here we write as 3 sine of 1/2 pi radians minus 3t. Find the velocity of the object as a function of t, and that would be it.
So when it asks you to find the velocity of something, that's just the derivative?
Yeah, if you're given the position function, yeah, the derivative of the position function is the velocity function. So like say this is like S of t. And S prime of t. And et cetera. Really don't need to, you don't need to go past, they don't need to go past dirt. Yeah.
So it's just a joke.
Well, it's not really a joke, but it is kind of funny, I think. Someone had to think of it. Like, what do we call it? Let's call it Snap Crackle Pop. Sure.
What is it?
Snap is the derivative of jerk, and the crackle function is the derivative of snap. You guys don't know Mr. Gross messing with us, or you? I don't know. It's like right on the edge. No, but for real, yes. Yeah.
And what comes after that?
Lock and drop, I believe. Yeah.
Snap, crap.
Sounds like you need to stop.
I'm not lying.
Velocity and acceleration.
All these things just happen. I don't.
I'm not lying.
You don't believe it? Is Mr. Gross messing with us, or is it you?
Yeah, I
legit?
was.
Oh man, I can't tell. All right, so next one, for 11. You'll forget to look it up. You'll never know. All right, so S is equal to. There you go. You don't really have to care because you're not going to go past jerk. Really? There's nothing after jerk?
Nothing.
Nothing?
Nothing at all.
Well, it'd be nothing if it were like quadratic, right? It'd be nothing but 0. All right, so.
Oh my God, snap, crap, pop.
All right. I would never be dishonest with you guys.
That makes no.
Cosine of pi.
Okay, so this would be. So this would be.
Cosine of 5c. Okay, so this is the position function, right? I don't care how crazy it looks. They say this
Right?
is the position function. So then S prime or S prime of t. All right, so here's the thing.
It's
real. Snap, crackle, and pop is real.
I would never deceive you guys.
Oh my God.
I would never deceive you.
Oh my God. And lock and pop is.
Wait, is that really what comes, is that the right word for pop, lock and drop? Is it?
Well, no, I can only find snap, crackle, pop. But like,
Okay, so
I don't know the else.
I'm thinking Rice Krispies right now, but anyway.
He's
So
alive.
here we go. So this guy, guys, this guy is a product rule, right? And this guy, this is the image you have to see. Okay, I see it. I have this constant, and I have this trig function, and then I have this over here, this term, I have this constant, and this trig function. So if we obey the rules of product rule, here we go. So the derivative of the first guy is 0, because this is just a constant, times leave this alone, sine of 3t, plus leave this guy alone, times the derivative of this guy is going to be cosine of, now we have chain rule built into this guy, times a 3.
Yeah, but it wasn't that
Right?
bad.
The derivative of this guy is here, right? Cosine 3t times 3, because right, you go all the way in. Right? Then you have plus derivative of the first guy is nothing, so it really doesn't matter what I write here, but I'll go ahead and write it out so it looks nice. Plus, leave the first guy alone, times the derivative of the second guy, which would be negative sine of 5t times, I would have to write second. That's what I think. Sorry, I couldn't fit on one line.
Wait,
Not your bad.
0. 0.
This is supposed to be a dot.
Plus.
Was your reaction similar when they discussed imaginary numbers for the first time?
Oh, it's real, it's right there.
Wait, negative signs and derivative cosine. Negative signs. So this.
All right, everyone good? Questions? Questions?
Wait, that's it. No.
I'm gonna clean it up, of course, simplify it. So here we go. So we have S prime of t would be equal to, this is nothing plus this guy, the 3. I notice I can move the 3 over here, and I get 4 over pi cosine of 3t. Right. I'm just bringing this 3 to all multiplication. I'm bringing the 3 over here and making it nice, and 3 and 3 simplify to 1 over 1. Plus that 0 plus this guy. Again, I'm going to bring the 5 out to the front, bring the negative out to the front. So I would have plus negative 4 over pi sine of 5t. Would be the first derivative of this, which is the velocity function.
Okay.
Wait, I'm confused. Sorry.
Questions?
So, it's, oh, because it's simplifying it. Okay, never mind, I'm good. We're good.
Cool.
Chocolate?
I cannot believe that Rice Krispies stole Snap Crackle Pop from derivative. I cannot believe that. Yeah, how about say original cute? Like, you know, it's kind of fun.
Yeah.
No, it's
They
a
probably didn't, they don't know math. They probably didn't. Yeah, I don't think that's. They didn't take good dance for They don't know calculus.
I don't think they were like, oh, these calculus terms are really cute. I'm gonna come up with a stereo company. Yeah, unless someone was like really bad at math, and that was the only thing that they were.
They were really loud.
Maybe just mathematician for 3 of that.
Where did the math people got it from? The series.
Yeah.
I think this
Is
is
this our
our
exit
ticket?
ticket? Is this our exit ticket?
stop.
Look at the time. Maybe the next one. I'll walk you through one, and then I'll let you do anything.
What the?
Walk you through one first.
Alright, F of you. Get it. F you.
Okay, and it says to find the value. It wants us to find.
What is that circle?
She's finding everything in
Let's make sure we're comfortable with this notation that we may have learned last year or the last semester or whatever.
Then G of X equals 1. Then Z equals 1.
So you're finding everything in half.
F of G prime. Okay. So U is G of X. So it wants us to find F of G prime. So what is F of G? Right. That's when you take. Remember the G, you plug it in, whatever that function is, you plug that into, for here, this guy, because U is G of X. So this is asking us the same thing to do, to find
G of X is 1, right?
F
X is 1.
prime
I can't read. Hold on. That I can't read that.
of G of X.
G of X.
So let's understand this. Let's understand this. Okay.
And so this
You could do F of G of X first, simplify that, and then say, okay, F prime of that, but this means the same thing as well. In fact, let me do that. So this is also a way of saying if you did F of G of X. So it's actually right. How I write this? I don't know if there's no way to write this that would make
Zero.
this is part
Just
fine.
write
It's
zero.
pretty,
Yeah. Okay. Yeah, that's the same thing there. Because g of x is the square root of x. So these all mean the same thing for these problems.
Cool. I like these things.
That is good to hear. Always good to hear. Okay. Let's see if we can get some more stuff on here. So, we're going to find this, which is that. So, f prime of the square root of this. Okay, take the first derivative of f and then plug in the square root of x.
Or you could.
Okay. So, this would equal to, what we could do first is,
do you have to?
I'm to G.
I'm going to explain this, it's
If it's
confusing, let's
f
see.
prime of that, then you have to take the, you have to take f prime first and then plug it.
See, we could do f prime of u, which would be 5u to the fourth, we could do that, and then just plug in, that works too, we could do that. So we could say it's going to be equal to, yeah, let's do that. That's a little bit clearer. That's a little weird for a while, let's do it. F prime of u is equal to 5u to the fourth.
Oh, wait, no.
Is equal to
Oh,
5 square root of x. We gotta be careful here, this is the fine details. This is going to be equal to this, and then times, because u could be some function of which it is, times du dx.
Wait, why?
Because that's what chain rule says. Chain rule says, okay, bring it, if you have like, for example, exponent, okay, bring it up the front, drop it down, and then times the root of the gut. Well, this u is probably some function of x, which it is. U is actually the square root of x. So let's not forget that. And then
Square
plus
root
a
of
0.
x is 1.
No. X
So
oh,
this
yeah, it would be.
is
Yeah.
equal to
So you, like, u is
5. Now u is the square root of x. So 5 square root of x to the fourth power times the derivative of this, right?
Why can't you?
Which is going to be, then this is x to the 1/2, so this would be equal to 1/2 x to the negative 1/2, the derivative of it, right? If you imagine the square root of x as x to the 1/2, that's easier to see, and the derivative of that would be 1/2
Why
x.
can't you go
minus
the other
negative
way
1/2.
and like plug in 1?
But like, it says that X equals 1.
Like, why can't you, instead of doing all that, plug in 1 for it instead of plugging in the square root of x? Because you already know what the square root of x is.
If you plug
You
in one,
already know what
if you
u
plugged
is.
in 1 right here,
You already know what
Yeah.
u is.
so if you want to say let x be 1, then g of 1 would be 1, so u equals 1, so you want to find f of 1. That's another way to do it. Yeah.
If you just, well, I'm saying you would have to find the derivative of the f function first, which is 5u to the fourth plus something, which is 5 times 1 to the fourth, which is 5.
Let's see if this works out. So we have f prime of u is this. So if we want to find specifically f at x equals 1,
That's
so
what I'm
let's see.
saying,
Let's see.
you
Let's
already
see.
know what
Let's
this
see.
is, like, it's all-
Let's see if it works. It works. F prime of 1 would be equal to, then just plug it in here. We have 5 square root of 1 to the fourth times 1/2 1 to the negative 1/2, which would be equal to, of course, 1 to the fourth 1, so you have 5 times, so 1 to the negative 1/2, same thing as 1 over the square root of 1, principal root, so you have 1 over 1 times 9, so 5 times 1/2, and this is just 1, and 5 times 1/2 is 5/2, is that what you have, 5/2?
No, we got 5.
It's 5/2, let's see.
Well, I don't understand how it could be wrong.
Yeah, it's 5/2.
I don't understand how it's wrong.
Okay, so this might be good because you understand it one way. So what exactly where did you start?
I started with x equals 1.
Okay.
So g of x equals 1. So you.
Now hold on. G of x is squared up. So g of 1 is 1. Yes.
G of x.
G of 1 is 1.
X equals 1. So g of x, g of 1 is the same thing.
No, g of x is just in general, like when x.
Yeah, but x is 1. Tells you that.
Yeah. So find when x is 1. So g of 1 is 1.
Okay.
Yeah, g of 1 is
So
1.
u is 1.
So u is 1. Mm-hmm.
Uh-huh. So you want f prime of u. So first you find the
Mhm.
f prime function, which is 5u to the 4th plus 0.
No, you're missing this.
That's only with chain rule.
Well, definitely we have to apply chain rule because
But
u,
it's not-
because u
it's
is
not
a
a
function of
product.
x.
There's no product there.
No, you definitely have to apply chain rule. So imagine that u is just any sort of function of x. Now I know it's specifically this, but then it would be 5. Bring the 5 to the front, drop this down, and then don't forget times the derivative of the guts.
What is the derivative?
That's
a what?
There is
Because whatever u is, u happens to be the square root of x.
Yeah.
even when it's not, like I'm ignoring all that and just finding the derivative of f of u, right? How we like any other time,
Mhm.
5u to the 4th. That's what I would say.
Yeah, it's you're missing. You're not seeing the whole
Because 1 is a
picture.
constant.
You're not seeing the whole picture. It's actually 5u to the 4th times du dx.
We never do that.
Yeah, you don't maybe not see it. So we discussed this I think in a previous class. So let's say you have y equals the sine of x. Okay, you want to find y prime. Y prime would be equal to the cosine of x times the derivative
I thought that was
Of-
with chain rule,
of x.
and you're not using chain
No,
rule.
and
you're
then
just finding
dx
the derivative.
dx is just ratio 1 to 1. So we just say
Yeah, but the
cosine
thing
x.
is, like,
X times 1.
Chain rule is
So you don't
product.
really, when they do this one, they just go right to here because the derivative of x with respect to x is just 1, so you don't see it. But the more general form that I like is like this. If you have something like this, sine of u. And then you say, okay, y prime would be equal to the cosine of u times du dx. So for example, let's say u is x cubed. U is x cubed. Y prime would be cosine of x cubed times 3x squared. So u is just some function of x. So this is a very general formula. This is like the purest, or it covers more material than just. It's true that y, if you have y equals sine of x, y prime is equal to cosine of x. But the only problem is that it doesn't give as much detail as this one does. Because they say, okay, whatever you're taking the sine of, okay, well if you do this and take the derivative,
We're not
you have to
taking
consider the inside.
Okay,
That's
so
why I
what if you just
prefer
have
this.
y of u?
What's
There's
that?
no sign. What if you just have y of u? Like,
Y
you
of
don't
u?
have any sign.
Y of u.
Yeah, that's all it is. It's y equals u. Y equals u to the 4th. Like, that's all it is.
I don't know if I'd say y of u.
No, y equals. I meant y equals.
We can talk about this more later.